Hello everyone, I'm Ángel Manuel Guerrero. I come from the University of León. Specifically for the robotics group, I will tell you something about our group in a minute. I came in behalf of Juan Navarro. This research is part of his master thesis that I advise. The outline of my presentation, you can see it in the screen. I will start by presenting my research group. Next, I will point out some context data because I need you to understand that this research is part of a bigger project and it could be difficult to understand if we don't know all the context. Next, I will start with the systematic literature review by presenting the methodology, the results, and finally, I will pose our conclusions. Regarding our group, historically we have been working in autonomous behavior on autonomous systems, specifically in robot systems. There are some researchers in our group working in computer vision and a few more working in haptic interaction. Probably thanks to the National Institute of Cybersecurity in Spain, in CIBE, we have a strong vocation in security. Within CIBE, we started to work in hardening autonomous systems, specifically robotic platforms. We have some interesting solutions in accountability and explicability for autonomous systems. And I think CIBE was happy with us because they invite us to join a project with CYL-HUB, the supercomputing center in Castilla y León, to detect malicious traffic in wide area networks that has nothing to do with robotics. And that's the project I want to tell you a brief information. Well, in this project, we aim to detect malicious traffic that could be an indicator of something bigger, such as advanced persistent threats. But we are not going to use conventional intrusion detection system that analyze network layer packets, but we are using flow data. Why flow data? I will explain in a minute what flow data is exactly. Why flow data? Because if we are working on very big networks, you can see in the picture a big network. This is Castilla y León. This network is Red CYL-HUB, which is the part of Red Iris, you will probably know it, in Castilla y León. It manages all the network traffic for all the universities in Castilla y León, the health official facilities, hospitals, governments, enterprise. So the amount of traffic that those routers manage is so big that you can use a conventional intrusion detection system to analyze or to look for some malicious traffic. That's why we use flow data. These routers usually gather flow data not for looking for malicious traffic, but for getting some statistical information about the movement of the traffic in the network. But we aim to use this information to have an indicator of any kind of malicious traffic. In this work, we are going to focus on SQL injections. So, for those who doesn't know what flow data is, a flow is just a set of packets, network packets, passing through an observation point, a router, for example, in a specific time interval. All the packets in the same flow share some features, such as the IP addresses and ports, both origin and source and destination. And of course, the timestamp has to be included in the time interval of the flow. And some other features, but no one related with the payload of the package. For instance, in a flow, we just have the number of packets in the flow, the total size of the packets in the flow, some TCP flags. So we lose not too much information required by conventional intrusion detection system to detect malicious traffic. Maybe you know some of those protocols. The most popular flow-based protocol is NetFlow, developed by Cisco. There is an open source implementation called IPFix, but probably NetFlow is the most used in the industry. Well, why we need a systematic literature review? Because there are not too many research about SQL injection attacks on flow data, and of course there are not any systematic review we can use. So in our research, we just want to identify which are the most commonly used algorithms, which of those algorithms performs better, and how other methods that are commonly used for preparing the data set for training, for example. Here in the screen you can see the research question we plan, we aim to answer according to what I have just said. Regarding the methodology of the review, we have used common scientific literature repositories. You can see it in the screen. We have done a keyword-based search, and we have used some inclusion and exclusion criteria to select some publications, some papers. Regarding the inclusion criteria, we just consider papers dedicated to detecting SQL attacks. We exclude papers, the oldest papers. We won't consider papers that propose SQL detection without using any AI-based algorithm, and we also discard papers from low-impact journals. Once we have some candidates to select our final selection of papers, we apply a quality assessment by using some criteria. Here you have the answers we must do a proposal must to output, but I'm not going to tell you have in the paper if you want the details. I mean, all the papers I'm going to show you has a score of 10 or more. These are the papers we have considered for this review. Here you have the references. You can, if you want to check them later, you can see it in the paper. And the results we have obtained are the following. Regarding the preprocessing methods most researchers apply, of course, as you may guess, normalization is probably the most commonly used. Not only normalization, but we can include here feature escalation and other techniques. Feature extraction is also very, very useful. It's you may as you may expect, and there are other methods that people use, but the most use has to do with normalization and feature extraction. Regarding the algorithms, there is half of the proposals use classic machine learning based algorithms, and the other half uses deep learning based algorithms. Regarding the machine learning algorithms, the most popular are ensemble methods, random forest, for example, and support vector machines. In this case, are also quite useful with quite good results. I will tell you later. And regarding deep learning, multi-layer perceptron networks and long short-term memory networks are the most commonly used. And regarding the performance, if you consider an average of the accuracies, there are several. One of the most difficult things in this research was to select a metric, because every proposal has different metrics, so it was, we considered several. Anyway, in the paper, we have made some average. This has to do with the accuracy, but there are other metrics you can see in the paper. Regarding the results, in all the papers we analyzed, the simple multi-layer perceptron networks obtains the highest result. And just for finishing, using AI-based algorithms for detecting SQL injection attacks on flow data, remember it's important, it's a promising research line. Nowadays, it is possible for a local area network to analyze, to use a conventional IDS, but in a few times, the 5G technology is coming, the number of packets will be so huge, but probably the number conventional IDs need to adapt. So flow data could be an alternative. There are several algorithms and methods that obtain good results, both from classic machine learning algorithms and deep learning. So depending on the problem, you could get better results using one model or one algorithm or another one. And our best, our major contribution with this project is that we have collected the techniques and algorithms that people is using in the literature. We have an important drawback. There are not many research on detecting malicious traffic on flow data. So the number of papers we have considered is very small. Probably it's too soon to consider our results as a general rule. So with time, there are many people working on this research line. We guess that that soon there will be a lot of work, and we will double check our review. Another thing we have seen in this research is that there are not too many data sets that a research can use for working with flow data. Most of the proposals use their own data sets, so it's very difficult to compare the proposals because every research is using his own data set, and changing the data set for trying another proposal is usually quite complex. So having high quality data set of flow data could be a good further work. We are working on that line too. And this is it. I'm happy to answer any question you have. So feel free. Thank you very much.
Any question?
My question is, what did you focus especially on the... So my question is, why did you focus on SQL? Because there are different NoSQL database, time series database. So what was the reason behind?
As I said, this is part of a bigger project. The final goal, we are far for that, is to detect advanced persistent threat. And we are analyzing several types of malicious traffic. We have worked with port scanning attacks, with denial of service attacks, brute force attacks, spam attacks, we are working with several types of malicious traffic. Juan, which is the work I'm presenting, is working specifically with SQL injection attacks. But the idea is to have as much types of malicious traffic as possible in order to have an indicator of a bigger advance. I mean, if one day you have some indicators of a port scanning attacks, days later you have a brute force attack, and later you get some malicious traffic related with SQL injection, you could think that there is something bigger that isolated attacks. That's the idea of the project. We are a lot of people working in this project.
Thank you. Any other question?
Hello, thank you. Yeah, have you taken into account time consumption of the algorithms due to you are dealing with flow of data?
Yeah.
So, I mean, I think you would like to have a real-time answer of the algorithms, right?
Yeah, that's our primarily concern, because even flow data, which in the end we are having 24 features per flow, but there are lots of packets. So even having flow data, only flow data, it's very computing demand. Besides the routers, for example, Red Kyler routers, I don't remember exactly the model, but are manufactured by Juniper, use a sampling rate. So they don't consider all packets to build a flow. They consider just one packet out of 1,000. So you lose lots on information. Even with that sampling rate, the amount of information to treat in real time, it's very big. At the moment, we have done it in a separate. So we have gathered flow data, and later we have working. Because Juniper says to CYL that if something was wrong, they didn't want to know anything. So it's a critical infrastructure. We can't play too much with that. So we would like to do it in real time, but I don't know if they won't let us.
Thank you.